problem, we are asked to complete the sentence with the word always, sometimes, or never. In a perfect square in standard form, B is a perfect square. Let's think about some of our options for a perfect square equation. So let's start with y equals x squared plus, let's go with 4x. And that is a perfect square. And it is positive, okay? But it could be negative. It doesn't say it has to be a positive, but let's just try it with a positive perfect square with a b value of 4. If my b value is 4, I know that my c value would have to be b over 2 squared, which is 4 over 2, or 2 squared, which is 4. So I know my c value would have to be 4. And that would give me the perfect square of y equals x plus 2 squared, okay? So it could be a perfect square. So I'm thinking sometimes or always. I think I've eliminated never, because we just gave an example where b was a perfect square of 4, and it turned into a perfect square. We have a perfect square with x squared plus 4x plus 4, which is equivalent to x plus 2 squared. What about y equals x squared plus 6x? So here, 6 is not a perfect square. And it is a value of 6, b equals 6. Let's see what it would take to complete that square. So c would have to be b divided by 2 squared, which is 6 over 2 is 3 squared, which is 9. So if I had a c value of 9, that would create the perfect square of y equals x plus 3 squared. So both of these equations are perfect square equations. Only one of them has a perfect square for b. So this is not always true. It is sometimes true that a perfect square has a b value that's a perfect square. Really, the b value just needs to be divisible by 2, and then we can square it to find c. This will include perfect squares, non-perfect squares, and other rational numbers.